Good morning, and this morning I'm here with you in Decatur, Georgia, United States of America, 1524 La Vista Drive, second floor, and on the topic CME / AMZ5x12MIPCA. Yours truly, Dolphy Gilpin. And I'm continuing from where I left off, my previous lecture, where I've stumbled upon a very important friend that went with us through our college years in chemistry and also in physics. The periodic table that's been with us in all our chemistry courses, seminars in chemistry through the Graduate Center, CCNY, organic chemistry, inorganic chemistry. It has been with us, the periodic table. We stumbled upon it via the magnetization property of the amazing 5x12 matrix and simultaneously the abundance of oxygen. We were doing something on oxygen and with the AMZ5x12 matrix, and via the magnetization property we came upon the periodic table. So here we are. And now we are stuck with it for a moment. Now we'll be choosing our random elements and random compound from our periodic table, and we will expand and expound upon them in random order, in no particular order. This morning I'm doing a rare thing. I'm choosing from not a popular element, but what we call a rare earth metal, and this one is symbol Y for yttrium. Now its correct pronunciation is I-T-R-E-E-M-E, yttrium, something like that. But I'm making a substituted pronunciation here for delivery's sake, for audio delivery's sake, of the Tanite tongue, and we call it yttrium. Whenever you hear me speak of yttrium, with the symbol Y, we are talking about yttrium, which was discovered by Gadolin in 1794. A Swedish scientist, named after Ytterby in Sweden. Now, yttrium as the symbol Y, as you see, is in group 1, 2, 3 of the periodic table, group 3, and period 1, 2, 3, 4, 5. Going in columns is the third column, that's group, and going in rows is the fifth row. That's period. So it's the third column and fifth row. And we find yttrium with the atomic number 39 and atomic weight 88.906. And just to give a couple of particulars about the yttrium, symbol Y, electronic configuration Kr, 4D1, 5S2, atomic number 39, as we said, group 3, period 5, atomic mass 88.906. Named after Ytterby, Sweden, discovered by Gadolin in 1794. Now, yttrium is among the transition the transition metals, which include some of the more well-known metals such as silver and iron. Now, the 17 rare earth elements include yttrium and scandium and 15 lanthanides, the metallic elements with atomic number 57 through 71. Now, the largest use of this yttrium is via its oxide yttrium, Y2O3, oxygen 3, which is used in making red phosphorus for color TV and picture tubes. It's also used yttrium to increase the strength of many alloys, such as magnesium and aluminum alloys. Yeah, this yttrium and yttrium oxide, in combination with other metals, is used to increase the strength alloys such as magnesium and aluminum. Now here we come upon a very intrinsic and important property of this yttrium. It's a medical use. Now, one of the medical use of yttrium, and in particular yttrium-90, a radioactive isotope of yttrium, it is used in the treatment of cancer. Using cancer treatment as liver cancer, and it's also used in precision medical needles to sever pain transmitting nerves in the spinal cord. Yeah, it's using precision medical needles to sever pain transmitting nerves in the spinal cord. All right. Medically, it's also used in radiotherapy, in a knee injury, a knee surgery injury, and in osteoarthritis. Yeah, this yttrium, is found used in radioactive isotope Y90 in radiotherapy in the treatment of osteoarthritis and knee surgeries, and as we mentioned, cancers such as liver cancer. All right, let's just turn over for some more properties with yttrium. Now, as we mentioned, yttrium oxide is the most important compound of yttrium, and it is used to make the high temperature superconductors, YBCO, which is yttrium barium copper oxide. Yttrium barium copper oxide, a superconductor. Now, other uses, you'll find it in LED, light emitting diodes. You find it have used in cell phones and large display screens, and in general lighting devices. No, it has how much? About 58 different isotopes, of which about 32 is radioactive, I believe, something like that. But we'll come to that in a moment. It's said here 50, but other sources have it 58, and every day we are having discoveries of different elements. Usually they are unstable and usually comprised of other elements in the lanthanides and actinide series. Over here we have now yttrium-89 is the most stable of the isotopes, and the source of this yttrium, we mine it from ores such as xenotime, which contain about 50% yttrium phosphate, other ores as monazite and bastreicite. Those are source ores that we derive our yttrium from. Now, other use of this yttrium is in one of the most widely used laser today, which is the yttrium aluminum garnet laser, abbreviated YAG, yttrium aluminum garnet laser, the YAG laser as they call it, which often contain other elements, and these elements change the kind of light produced by the laser. In one way or the other. Now, this yttrium is very reactive with the halogen family, and as you know, the halogen family consists now of this chlorine, bromine, iodine, this is fluorine, chlorine, bromine, iodine, acetine, and this one here. So all of this in this particular group 9, I believe here, of the periodic table, the halogen family, yeah, you find that the yttrium react with these halogen family easily. And in particular, what you have is yttrium-3 fluorine, fluoride, yttrium-3 chloride, yttrium-3 bromide, yttrium-3 iodide. And these are other in the family and the halogen family there. But those three are 1, 2, 3, 4 mentioned. The popular ones: the fluorine, the bromine, the chlorine, and the iodine. And it's 3. Now it usually reacts with a valence plus or minus 1. It can react with a valency of +1 or with a valency of -1. And here I have now the electronic shell, a 281892. And when you add up this, that will be 39. A color, silver white. Its crystal structure is hexagonal. This sort of a hexagon shape. That's the representation, hexagonal crystal structure of yttrium. And it's stable at 20 degrees centigrade as a solid, and so on. But let's just now focus on the medical use of this yttrium, as we said, in this radioactive isotope Y90, used in the treatment of cancer, and used in radiotherapy, and used to treat osteoarthritis and in knee surgeries, and in precision medical needles to several pain transmitting nerves in the spinal cord. So that's some of the medical use of this yttrium. Like I said, I'll be doing something rare, and by nature, this is what? Rare earth metal, this yttrium, with atomic number 39 and atomic weight 88.906. All right, what we'll do, we'll be taking a break from this yttrium, and we'll come back. We'll be dwelling on this yttrium with some other properties and uses, and we're bringing in the periodic table, which was not rediscovered, but it was laid dormant with respect to research for a moment relative to me, but I stumbled upon it once again by the magnetization property of the AMZ5x12MIPCA in particular. So we'll be looking at the periodic table, and we'll be focusing on certain elements and compounds, especially elements with in the hydrocarbons, the nitrogen, oxygen, carbon, hydrogen, and sulfur and phosphorus. Some of those more popular ones with the hydrocarbons that usually form certain pharmacochemical compounds in the pharmacy there that you use to antibiotics and other drugs used for pain, analgesics, anesthetics, and so on. But we'll cross that bridge when we come to it using our periodic table. Let's take a break, and we'll return to our yttrium correct pronunciation, yttrium. But like I said, I'm substituting this pronunciation for this video lecture as yttrium. Symbol Y, atomic number 39, and atomic mass 88.906.